say a FIFO queue. Do you have any other kind of queue? Queue is always FIFO, right?
Right.
It's like you say a Colombian person from Bogota. I mean, that's already Colombia, right? Doesn't make sense. You understand what I'm saying? It's redundant. So it's saying a FIFO queue. So here also says a LIFO stack. I mean, it's like, but anyway, let's talk really sizes then. Okay, so same idea. You have a queue, and says star means getting the following sequence, blah, 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 blah. Same thing, right? Letter is enqueuing, star is popping, dequeuing, right? Good. So we have E, A, S, then star. So what do we lose? E. Good. We stay with that, right? Good thing it has just one S, right? And then we have a spotlight. And then what do we have? Another star, right? Okay, then Q, right? U. Okay, then three stars. So we go all the way here, right? We came with UE, right? And then ST, and then 3 stars. We just have the T, right? We have a T only, right? And then IO, then 1 star, right? And then then 3 stars. Right? Very easy, right? So, so you see, guys, stacks and queues, I think, are the easiest topics, right? From all that we have seen. Which one has been the hardest? Recursion. I think recursion is always one of the toughest.
I don't like linked lists. Linked list sucks.
Linked list was the hardest?
Yeah, for me, yeah.
Linked list is also very tricky.
Yeah.
Once you start playing with them, right?
I don't like linked lists.
No.
You don't have good memory.
No, I remember how to do it. I just don't like it. It was difficult for me to
You learn a lot because you ended up doing everything on your own pretty much, right?
Yeah, but linked list was tough.
Yeah.
Everything else was alright. Linked list was tough to learn.
Yeah.
The thing is that you have to conceptualize everything. Did you do this exercise already?
Yeah, we did this.
You did 10, but you had to do 8. I told you to do 8, remember? I did 9 here in the class. Did you do multi-pop? In the last one. Show how to implement a queue using 2 stacks. I told you the answer, right?
Yeah.
What was the answer?
Fill up 1 queue.
2 stacks.
I mean, 2 stacks. Pop one.
Feed up 1 stack.
1 stack to the other one.
Pop it, and as you pop, push it in the other one.
Yeah.
And then pop again, and then you have them in order, right? Simple, right? So after you have the second stack filled, every pop will be like a DQ, right? Because now it's in reverse order, right? Okay, let's see what else we can do.
With the balance of unbalanced one, you first push that all in the stack, right? And then you put it in the pocket and see if that's equal to the last one, then you know it's
It's not gonna be equal.
or balanced.
It's not gonna be equal. That's the big mistake that everybody makes in that exercise. It's not gonna be equal, really. Because if you find this, the part is this one, right? This pair is this one.
Right.
So it's not the same.
So what's the intention of that one? Do you mind showing that? Or, I don't think I understand what the objective.
The objective is simple. I give you a string like that. It could have more stuff, and you have to tell me. For this expression, for example, for this string, you have to return true, because everything is balanced. But if I were to give you something like this, you would return false. So what you do is you start pushing as long as you have openings. Okay? As long as you have openings, you push. And then, once you find a closing, you pop. And when you pop, this is what you're going to pop, right? You're going to see if this guy is the match of this guy. Not the same guy. This is one big mistake. People think that they are going to pop not the same, but a matching pair. Correct, because look at the shape, it's a different character than this one, but it's the matching pair. Then if they match, you keep looking. If what you have here is another opening, then you push it. If you have a closing, like here I have another closing, sorry, here I have another closing, right? You pop again. Every time you find a closing, you pop and see if they match.
So they're already all inside the stack. They're already.
All the openings will be in the stack, right, up to that point. You receive a string and you start going character by character. If the character is an opening, push. If it's a closing, pop and compare if it's a matching. If it's not a matching, return false and you don't have to do anything else. And if you finish with analyzing the whole string, if you finish analyzing the whole string and your stack is empty, then everything is paired, is balanced.
How do you know it's matching?
You have to have some logic there. You have to have just say a method that returns Boolean, that if you pass a character, you pass a char C. And this method returns true or false, analyzing. That's your stuff, right? You got it, right?
Yeah.
This is the same exercise, right? I could give you snippets of code like these two for you to try. What do you think I'm gonna do? I'm gonna do 7 and 8, and I'm gonna start with stacks and queues to start with GUI, okay? I'm gonna solve 7 and 8, and I'm gonna give. You can go and type this page if you want. Info CS, that's CS, application that is you, Java, for the CS stuff. Write it down and send it over, okay, Greg?
Yeah, sure.
So I'm gonna play with example 7. That's a start, and then I'm gonna do a queue, and then you're gonna see what happens. So it says what happens with that code, what is the output of that code when n is 50, right? Okay, we create a stack, n is 50, right? I'm gonna write it here, these people in the wall. N is 50, right? Okay, it says, well, n is greater than 0, 50 is greater than 0, yes, it is greater than 0. So it says push the remainder of dividing n by 2. What's the remainder of dividing n by 2? 0. So you push 0. And then go back, and then n becomes half of it. So n now is 25. Right? N is greater than 0? Yes. Push the remainder of this divided by 2, which is
1.
1. Now n divided by 2, n becomes 12, because it's an integer division, right? 12 greater than 0, yes. Put a 0. And now n becomes 6. Remainder, 0. And n becomes 3. Remainder, 1. And n becomes 1. Okay, now, remainder, himself. And n becomes 0, you get out of the while. Now it says, well, the stack is not empty, keep popping and see what you print. So what you're going to print is 1, 1, 0, 0, 1, 0, right? Binary number, you want to say, right? And guess what's that? The binary representation of? There you have another logic for doing the binary conversion. I showed you one yesterday, it's quite different, right? Got it? Yes, Corey.
Can you tell me again how you did the math? Like, you did 50 divided by 2, and go down.
If you see the logic, it says, when n is greater than 0, the first time n is 50, right? So 50 greater than 0, yes, so you get inside the while. It says push the remainder of n divided by 2. 50 divided by 2 is, the remainder is what? 0, right? It's the exact division. So you push 0, that's why 0 goes to the very bottom. N becomes n divided by 2. N will become 25 for the next iteration. The next iteration says, is n the remainder of 25 divided by 2, which is 1, because 25 does not divide 2 exactly, it has a remainder of 1, right? And then you're going to push 1, that's why 1 appears on top of 0, you see? And then n becomes 25 divided by 2, integral division, which is 12, correct? So the next time you go with n12. And there you go, keep going, until n becomes 0. Yes,
When n is 1, how did it become 0?
when n is 1, sorry?
When n is 1, how did it become 0? I mean,
Because when you make a division of, this is what happens. Finally, you have n equal 1, right?
yeah.
The condition says y leg is greater than 0, yes, 1 is greater than 0. 1 mod 2. 1 divided by 2, quotient 0,
Yeah.
remainder himself. So you push 1, that's why you push 1 at the end. And then n equal n divided by 2. The quotient is 0.
Oh, I see.
Got it?
Okay.
That's how it becomes here. Is that clear? Not a problem, right? That was very simple. Now, let's do the same exercise. I think below we have something with, what does the following code fragment do? Oh, here we have the answer actually, right?
Yeah.
Okay, fair enough. But you know, if I ask you in the exam this question, you will have to show me this, right? If you give me that answer, you fail. You understand, right? Just to give you, just to not to stress you too much. So now we have a stat. So I guess here it doesn't say. Okay, what does this code do? Can you analyze it? What does that piece of code do? 8. Question 8.
Pushing whatever you need to from Q until the Q is empty. And then after that, then you just swallow the stack.
You're redoing it again.
So if the Q say contains 1, 2, 3, what happens with that Q?
Push 1, 2, and then 3.
It comes out as 1, 2, 3. And then it gets
And then you
reversed
pop
again.
them, so you get 3, 2, 1. And then that goes into
I might end up 0. You go 1 to 3.
Nice.
Oh, no, it remains.
You know
1
what?
to 3.
You know what? If you cannot do it mentally, do it in a piece of paper. Let's say you start with a Q that contains 1, 2, 3. 1 is the first element in the front. What will happen? The stack is virgin. It's a virgin stack. Stack equal new stack. It says there, right? It's an empty stack. Totally virgin. So
return -1 if there's nothing in there.
yeah, but there is no problem with -1 there because
You get it.
well, it's not
If you
empty.
DQ, you pop in 3 of them, so that you
No,
remain
but
0.
look, it's taking care of that. It says, well, it's not empty. So it's only gonna pop and it's not empty.
I think the Q will have the same numbers, but reversed.
Yeah.
You have 3, 2, 1.
It's like the 2 stacks again.
Wouldn't it just be 1 to 3 again?
No,
So 3, 2, 1.
3 to 1?
Why don't you guys try doing it on a piece of paper? Try doing it. Say you have a Q with elements 1, 2, 3, where 1 is the front. See what you get. If you try to do mentally, you might not be there yet. So do it in a piece of paper. Done?
So you said that Q is equal 1 to 3.
Sorry?
You said Q is equal 1, 2, 3?
Yeah. Always remember, here it doesn't tell you what the Q is, right?
Right.
But make your life simple. Play with any Q. The smaller, the better. Not too small because if you have one element, you're not going to do nothing. But if you have a Q of size 3, then you can make some manipulation. And it's simple. It's not just 3. You figure out? Yeah, perfect. You got it. Simple, right? You got it? What's your final Q at the end? How's your Q going to look at the end? You have just one stack. You're drawing two stacks there. You just have one stack. Yes, so watch out.
is that? For the queue, is it?
Just draw one line.
Draw
Like
one?
an array.
Okay.
Remember, which one is your phone? Normally your phone is the one that goes to the
It's kind of confusing because you're pushing the DQ at the same time.
Yeah.
Got it?
So the whole thing is it's kind of confusing because you said it does the push and DQ at the same time.
You're not from this class, right? Yes.
Yeah.
No, I don't.
Is a visitor?
That's the class.
Smith? Another deserter? How many Smith people do we have? 3, right? Okay. That's good. That's good.
Maybe I should bring the whole class over here.
Maybe Smith too? You guys are... Okay. Yes. No. This works for any queue. I'm saying just to understand how it works, assume the QQ has just 3 elements. 1, 2, 3. That's it. No problem.
Sí, class.
Si lo ves a Black, dile que venga a dar el examen ahora, si puede. ¿Quién? A Vladimir. Black. Okay.
Yo lo llamo ahora.
Ya, está bien. Got it?
What I was thinking was stacked on top was that it reversed first before it was pushed into the queue. But it's not.
Yeah, Stack is going to put them in reverse order. Then when you pop, you're going to get them in that reverse order.
It was that.
You have just one stack.
Yeah, this is the one step.
What is the other one?
This is the queue. This is how I created the queue.
Okay.
See, this is the front. 1, 2, 3, and then it goes down here.
Okay, fair enough. Fair enough. Fair enough. Fair
This is
enough.
your proper way to.
I normally draw these stacks horizontal because they are easier to understand which one is at the front. Horizontal.
How do you draw a queue?
Accuse that fine like you did it.
Okay, so.
My bad. The stack is fine how you did it.
Okay,
The queue normally I draw it horizontally.
this way.
This
Which
way.
way is the front when you draw horizontal?
Always from left to right. Like an array.
Okay.
Okay guys. Some of you have noticed what happened, some of you haven't. I'll do it quick. The way it works is like that. We're gonna assume for a sec that the queue has 1, 2, 3, these elements. Okay? Then it says stack new stack, so my stack is virgin. Stack S. Okay? Then it says, well, queue is not empty. Push every element you DQ, pretty much say. So if I DQ, this will be my front, right? Assuming a simple queue. So I'll push 1, then I'll push 2, and then I'll push 3, because that's how I DQ, that's in that order, right?
Yep.
So this is how the stack looks. Then the while says, well, the stack is not empty, NQ every element that you pop from here. So my queue, after this procedure, was left like that, empty, right? After this is step 1, after step 1, my queue is empty, right?
Yep.
Now, I've got to take elements from here and NQ them here. I pop 3, that's my new front. I pop 2, and then I'll pop 1. So now the stack will be empty. In this stage, my stack was like that, right? 3, 2, 1, right? I pop 3, I put it here. I pop 2, I put it here. I pop 1, I put it there. So my stack is empty and the queue is like that. Reverse. Got it? Clear?
So the stack again was 3, 2, 1, right?
Yes. So when you push, you put them at the bottom. The first element you get, you put it at the bottom.
So the last part? The last part that you put, you have a queue,
Here, on step 2,
right?
so, okay, up to here
Right.
is what I have done. This is step 2. These 2 lines is step 2.
While it's not empty?
The last 2 lines is step 2. What I'm putting here is 3.
Okay.
So stack is here with 3, 2, 1, right?
Right.
I say, well, this guy is not empty, pop and Q. Pop and Q. Pop and Q. Pop and Q. And this guy should be empty because it has popped all of them. And now my Q looks like that. Got it?
So looking at Q, DQ, and stack dot push, which one of those do you do first? The Q, DQ, or stack dot push?
Which one? The third line? The third line?
Yeah, which
Oh,
one?
yeah. You always need Q and then push.
You do what?
You mean line, right?
Line three, yeah, what is the?
You're saying, which one will I do first, this guy or this guy?
Right,
Logically, if I wanna push, I need to know what I'm gonna push.
you have to
So
DQ
this has to be done
first.
first, correct?
You have to push first and Q, oh,
You have to DQ first, and then push.
okay,
Because if you don't know what you're DQing, how do you know what you're pushing?
okay.
Got it?
And the other one, you do the stack first and then NQ. Okay.
Correct. That's in the last line, you pop first, and then now you know what you got after popping. Now you push.
Thank you.
What you do.
EQ and push. Okay.
Got it? Still, we're very way behind, right? What did you guys do after this?
Well, actually, he covered this, and then he linked list, and then he moved to go.
Really? Think this was after stacks and queues?
Yeah.
Wow, he took a different order, right?
Yeah.
He didn't do trees or sets or hash maps. Okay, that's not part of Java 2, but I like giving you a little bit of that because you eventually do computer science or and you see them, at least I want you to have an idea of what they do. I'm going to show you in a second.
The exam will be the 18th, right? So remember last class, he said we had 3 more classes.
You can play with, okay?
That makes no sense. Last class he said we had 3 more classes. But that makes no sense if the 18th is the 18th.
Yes, for evaluating expressions.
Exactly.
Qs or stacks?
So you would think you would
Depending,
do
if you
final
have a
exam on final
postfix
week,
expression, you use stacks.
but no.
Remember the postfix when you put, for example, you do normally 4 plus 3, right?